We'll handle this new try expression form with a new expression variant, try E. It has a body expression and a handle expression. The body corresponds to the part that we tried to evaluate, and as long as it has no exception, that's the result. And the handle expression corresponds to the part that's inside the lambda empty. We don't need to remember the lambda empty, just like we don't need to remember the name try here, because it's always the same. So we've got two sub-expressions in a try E. We will need to extend parse so that parse of this expression produces a try E where there's an add expression for the body and a number expression for the handle expression. Extending parse is a straightforward exercise at this point, so let's move on to the interpreter. To interpret a try E expression, we've got two expressions, body and handler, and of course we should start by interpreting the body. So that's a recursive call to interp. In case we need the handler, we have to put it in the continuation. So there's a new try k continuation form that'll have a handler expression and of course the handler's environment. When we get a value back from this body, then we will be in the try k case of continue. If we got a value back, that means there was no exception, so we should just continue with the rest of the continuation using that value. In other words, if there's no exception, no error that happens, then we don't need h or env. So if we don't use h and env here, then when do they get triggered? Well, we have to make a different change to our interpreter. Where we were raising error v and just not using the continuation, now we're going to use an escape function. Right? If we have a value, we continue using the continue function in k. If we have an error v, pseudo value, then we escape using escape k. And escape is going to look for the nearest enclosing handler in the continuation. So let's look at what escape should do. It takes a continuation and an error value. If the whole continuation is you're waiting to add to 3 and then you'll be done, that means that there was no try wrapping the current continuation. So in that case, when you try to escape with an error v, then you just throw away the continuation and produce error v. There's no handler. On the other hand, if you are in a continuation that is waiting to add to a number, but then outside of that it has a handler expression num2 in the empty environment, then escape with this error should discover the try k and it should jump to evaluating this body expression with the rest of the continuation. So when we evaluate 2 in the done k continuation, we should get a 2 out. If that continuation is bigger, so here we've got the same sort of scenario, we've got a continuation handler, the expression is 2, but the continuation outside of that handler is bigger, it involves adding to the number 3, then what we should do is evaluate 2 to get 2, add it to 3, and that's how we get a 5. So with those examples, we can consider escape on the different cases, and escape doesn't really care about anything except try case. So when it sees a done k, that means it just has to return a value. When it sees anything with a next k that's not a try k, then it should keep trying to escape for the rest of the continuation. But as soon as it finds a try k, then that's the handler and the environment that it should start interpreting. And when it gets a value back from the handler, then it should continue with the rest of the continuation. So that's why we have interp h, env, next k.